Right, in this lesson, we're going to have a look at some general solutions of trigonometric equations. Right? Now, to start with, why do we even need general solutions for a trigonometric equation? The reason being the values of the sine and cos and tan function, because they repeat after every period. If you take a sine or cos function, you might get two solutions for every cycle. Similarly, for a tan function, you get one solution per cycle. Right? And because the values repeat itself over a period of time, it is easy for us to consider a general solution, and then with the help of the general solution, we can then work out the exact solutions given a specific domain. Right? So to start with, these are the three statements you need to know. So if you take a cos function, right? Now for a cos function, if you look into our four quadrants C, A, S, and T, right? So obviously, if you take the values for cos being positive, right, they're on either side of that x-axis there, right? And that's why we have the 2n pi plus or minus the cos inverse of the angle that we're looking for, right? Similarly, if I take my tan function, my tan function is positive in the first and the third quadrant, right, with the distance between them being pi, right? And that gives us the general solution for tan as x is equal to n pi plus tan inverse of the angle of the answer basically, right? Similarly, if I take my sine function, right? Sine function is in the first quadrant and the second quadrant. Now this is the solution for the rotations in the first quadrant, and this is the solution for the second quadrant, right? Now let's jump straight into this question, right? And obviously these quadrants are going to be different if we're dealing with a sine, cos, or tan ratio where the answers are negative, right? So that's going to be in the different quadrants based on whether it's positive or negative, right? Now let's just jump straight into this example. The question states, find the general solution of 2 sine 4 pi x plus root 3 equals 0, and hence find the solutions between the interval minus 1 to 1. Right, so to start with, right, we're going to go ahead and first make sine the subject of this equation, right? So we have 2 times sine 4 pi x plus the square root of 3 equals 0, right? So if I make sine the subject, I'm going to get sine 4 pi x is equal to minus the square root of 3 on 2. But obviously in this particular example, we're dealing with sine being a negative value, right? So if I take into account sine being a negative value, right, we're basically dealing with the third and the fourth quadrant, right? So what we're going to first do is we've got to basically still find the answer for the sine inverse of the minus square root 3 on 2. So we basically have to still find the first solution for that, right? And the first solution, so sine minus square root 3 on 2. So sine is square root 3 on 2 in the first quadrant when the angle is equal to pi on 3, right? So which means the angle in the second quadrant is going to be pi minus pi on 3, which is going to give us the answer as 2 pi on 3.
Right, now that we've got the answer for this particular question as 2 pi on 3, right, what we're going to now do is we're going to represent that in the form of a general equation. Now, in this particular question, we are actually solving for sine 4 pi x is equal to minus square root of 3, right? Which means the solution for this case is not just going to be x equals something, it's going to be 4 pi on x is equal to, the very first general solution is in the format of 2n pi plus sine inverse of a, right? So 2n pi plus the sine inverse of a, which is what we have here, right? So this is basically same as sine inverse of the answer, which we've just figured out is equal to 2 pi on 3. So I'm just going to make it as 2 pi on 3, and if I make x the subject, right, which I can do by dividing both sides by 4 pi, right, so I can divide both sides by 4 pi, I'm going to get x is equal to, right, 2n pi on 4 pi is just basically going to be n over 2, plus, now here I have 2 pi on 3 divided by 4 pi, right, so if I convert that into multiplication, times 1 over 4 pi, right? That is basically going to simplify itself as 1 over 6. The pi's are going to cancel into each other, and it is simply going to simplify as 1 over 6, right? So So what we can now do is we can actually make it into one single fraction, right, which is going to have a common denominator of 6, right? So it's going to be x is equal to 3n plus 1 over 6, and that's going to give us a very first general solution to this particular question. Right, now we do also have to take into account the second equation that we have on the top, right? The second equation is x is equal to 2n plus 1 times pi, take away sine inverse of the answer, right? So which means I've got to write an equation for this particular setting too. So which means 4n pi is equal to 2n plus 1 pi, take away the sine inverse of the answer, which we know is equal to 2 pi on 3, right? My bad, I've just made a mistake here. This is 4 pi, x is equal to 2n plus 1 pi, take away 2 pi on 3. Right, now again we're going to make x the subject, which means we've got to divide both sides by 4 pi again. Right, if I divide both sides by 4 pi, I'm going to get x is equal to 2n plus 1 over 4, take away, we've already discussed 2 pi on 3 divided by 4 pi, which is giving us 1 on 6, right? Making them the same denominators. If I make them the same denominator, which is going to be 12, right? So 3 times 2n plus 1, take away 2, right? Which is going to further simplify itself as 6n plus 3, take away 2, right? Or in other words, 6n plus 1 over 2, and that's going to give us a second general solution to this particular scenario. Right, now we're going to go back into the domain of this question, because finding the general solution was only one part of this question, right? So the question basically states, hey, find the general solution, but also find the solutions for x in the interval minus 1 to 1, right? So we are dealing with a sine 4 pi x function. So if I take into account my sine 4 pi x function, right, which is basically going to have a period of 2 pi on 4 pi, which is just simply a half. So between the domain minus 1 to 1, right, we should be able to fit 4 cycles of this function, right? And we know that for a sine function, we're going to have 2 solutions for every cycle, which means for this particular question, we're going to be dealing with 8 solutions for the scenario. Now, in order to find the solutions, right, what we really need to do with the general solutions, we need to start substituting values for n, right? If it is in the positive direction of the x-axis, right, we need to start substituting the value for n as 0, and then followed by 1, 2, and so on and so forth. Similarly, on the negative direction of the x-axis, we need to start substituting the values as minus 1, minus 2, and so on and so forth, right, as we go further away from the y-axis. So that's what I'm going to do to both the general solution, right? We're going to start substituting values for n until we go outside our domain, which is in this case is minus 1 to 1, right? So let's start with the very first one. So if I substitute x, say x is equal to 3n plus 1 on 6, right? So we're going to start substituting values. When n is equal to 0, we're going to get the solution for x is 3 times 0 plus 1, which is nothing but 1 on 6. When n is equal to 1, we're going to have x is equal to 3 plus 1, 4. 4 on 6 simplifies as 2/3. N is equal to 2. 3 times 2 is 6. 6 plus 1, 7. 7 on 6 is a number that is going to be greater than 1, which in this case falls outside the domain we're dealing with, right? So which means that finishes the answer for that particular section. Right, now let's look at the second solutions that we have. So we need to also start substituting n as negative numbers, because there's some values on the left hand side of the y-axis, right? So which is what I'm going to do next. I'm going to start substituting n as negative 1. So when n is equal to negative 1, right, so when we substitute n as negative 1, we're going to have x is equal to, right, minus 3 plus 1 is minus 2, and minus 2 on 6 is going to be minus 1/3. And then finally, when n is equal to minus 2, right, we're going to have x is equal to, right, minus 2 times 3 is going to be minus 6. Minus 6 plus 1 is going to be minus 5 on 6, and obviously that value is pretty close to -1. So those are all the 4 solutions we're going to get with the help of the first general solution, right? Similarly, we need to do the exact same thing for this general solution. X is equal to 6n plus 1 on 12, right? And again, we're going to start by substituting the values for n. So n is equal to 0, x is going to be equal to 1 on 12, n equals 1, x is going to be equal to 7 on 12, when n equals -1, x is going to be equal to -5 on 12, n equals -2, x is going to be equal to -11 on 12, right? So just the same thing, but we're just substituting the values into the second general solution. All right, and that should complete this question. So we've got 8 solutions. We talked about having 4 cycles in the domain -1 to 1, right? So we have 8 solutions, and those are our 8 solutions in this particular scenario. All right, that's it from me today. Thank you for watching, and have a wonderful day. Thank you.